Good day, everybody. We're here today to talk about radians, arcs, and sectors. Well, that's what section 11.7 is about. We're going to talk about radian measure in particular. Two things I'm going to accomplish within this video. I'm going to teach you what a radian is. All right, it's not just a mode on your calculator that you're not supposed to use. Actually, by the end of this video, maybe you'll realize there is a use for it. And secondly, I'm going to want you to be able to convert angle measures between degrees and radians. Now, when we're talking about radians, all we're doing is talking about another way of measuring an angle, and well, let's take a look at that right now. What is a radian? Well, a radian is another unit of measurement for an angle specifically. You know how you can measure distances in feet or yards or meters, kilometers? There's different units. Well, angles can be measured in degrees, they can be measured in radians, they can be measured in gradians. There's different units of measure that you can use for angles as well. You're just only used to using degrees. Okay, well, there's a very specific definition for what a radian is, and I'm going to teach that to you right now. A radian is simply the size of an angle, the size of a central angle in a circle, which intercepts an arc that is exactly the same length as the radius of the circle. Now you see I've drawn a radius of the circle, and what I'm going to do is I'm going to create an angle that's going to intercept an arc of the circle, and the length of that arc is going to be equal in length to the radius of the circle. So we're kind of curving the radius around here. So let's say that this distance right there is equal to the radius of the circle. There's another R. Then this central angle that forms or intercepts that arc would be defined as being 1 radian in measure. All right, so I'm naming this angle right here theta, that central angle, and I'm telling you that the measure of that angle is 1 radian. All right, just like you can call an angle 17 degrees, for instance, not this one. You can say that this one is 1 radian wide from here to there. Now, it doesn't matter what size the circle is. Whenever you're talking about a radian, what you're talking about is an angle whose intercepted arc is the same length as the radius. So, again, I drew a different size radius in this circle because, well, the circle is a different size. Let's say that that arc right there is equal in length to the radius. Well, then this angle from here to here would be 1 radian wide, so to speak. Okay, so that's what a radian is. Now, I need you to have an idea of what the size of a radian is compared to a degree. And so I want to go next to asking this question: how many radians can you fit in a circle? Now, really this question comes down to this. How many times can you take the radius of a circle and wrap it around the circle until you've gone 1 full revolution around? Okay, so if I keep adding 1 radian and another radian, how far around am I going to make it? Now, it turns out the answer to that question is hidden within a formula that you have used quite a lot in your lifetime. And I ask how many times the radius of a circle can fit around a circle. Well, hopefully one of the things you think of when you think of around a circle is the circumference of the circle. And that's the formula that has this answer hidden. You know that the circumference of a circle is equal to 2 pi times the radius in length. Well, that means this quantity right there, 2 pi then, is the number of radii that you could wrap around the circle. And so that also means that's how many radians there are in a circle. There's 360 degrees in a circle. There are 2 pi radians in a circle. All right, now there's exactly 2 pi radians. Maybe it's helpful to think of it this way. Since pi is approximately 3.14, that means there are approximately 6.28 radians in a circle. Now, I didn't draw my angles perfectly 1 radian in size, but if I could, I would have 1, 2, 3, 4, 5, 6, and a little bit more than 6 radians going around the circle. Now keep in mind, the radian again is the angle measure, it's not the length of the arc right there. Those are separate things. All right, now along those lines, how many radians then how many degrees are in a single radian? Clearly, I need to ask that question rather than the first one because there's a lot more degrees in a circle than there are radians, right? Well, if there are 360 degrees in a circle and 2 pi radians, then I can use this proportion right here to figure out how many degrees there are in 1 radian. We can say that 2 pi radians, which, by the way, you can abbreviate radians RAD. 2 pi radians is to 360 degrees, as 1 radian is to x degrees. Now, just ignore the units here. Let's just cross multiply. All the relevant units will kind of cancel one another out. We'll have 2 pi x is equal to 360. And so x then would be equal to 360 over 2 pi. Now, I'm going to change that to an approximate value in a moment because you probably don't know what 360 divided by 2 pi is right now, and that's fine. But I do want to simplify this in its exact form, and you'll see why here in a little bit. 360 over 2 pi is the same thing as 180 over pi. Now, what that basically tells me is that there's 180 degrees in 1 pi radians, just like there's 360 degrees in 2 pi radians. All right, and what is 180 divided by pi? Well, it's about 57.3 degrees. All right, so a little less than 60 degrees in 1 radian, which makes sense because there are 6 60-degree sectors in a circle, and there's a little bit more than 6 radians. There you go, some logic there. All right, now you should know what a radian is at this point. That was the first goal of this video. The second was for you to be able to make conversions between angles that are measured in radians and angles that are measured in degrees. And let's talk about then how you go from radians to degrees. I've actually kind of shown you one method using a proportion, and I'm going to kind of build on that idea right here. Now, I'm looking at a unit circle right now. That's probably the easiest way to go. And you know in a unit circle that this would be a 0-degree angle right there. Well, that's my starting point. If I were to go all the way around the circle, you know I would have 360 degrees. Well, hopefully, clearly, there are 0 radians in 0 degrees, right? I'll write the radians in orange. And we've stated there are 2 pi radians in 360 degrees, correct? Well, if we go halfway around the circle, this is something I mentioned in the previous slide. You go 180 degrees to get halfway around the circle, right? Well, halfway from 0 radians to 2 pi radians would have to be 1 pi radians, right? So there's 1 pi, or just pi radians, at 180 degrees. Okay, now if you will use this kind of as a reference point, it will make changing a degree measure to radians a very simple thing to do. Think about, for instance, how many radians there would be in 90 degrees. Well, 90 degrees is halfway from 0 degrees to 180 degrees, right? So if I want to know the radian measure that corresponds with that, I want to know what's halfway between 0 and 1 pi. Well, that would be 1/2 pi, or pi over 2 radians, correct? By the way, I've been writing RAD here, but whenever you write down an angle, if you want it to be in degrees, you have to use a degree symbol. But if you decide not to write any units, it's implied that, such as this right here, it's implied that the angle is in radian measure. All right, so I don't actually have to write that. Now, if I wanted to know how many radians there are in, say, 135 degrees, right there. Well, 135 degrees is 3/4 of the way from 0 to 180. And so that would mean that there would be 3/4 pi, or 3 pi over 4 radians. Does that make sense? Now, every time I was trying to figure out what portion of 180 degrees I had, and that was how I had figured out what portion of pi the radian measure would be. Okay, so here's how you go from radians to degrees. I'll write this out then to show you how it works with the radian and degree equivalents that I've already shown you. The degree measure of an angle can be found if you take the radian measure and you multiply by kind of our conversion factor, 180 degrees over pi. There's 180 degrees in every 1 pi radians. All right. So, for instance here, if I wanted to convert 3/4 pi radians into degrees, I would do 3/4 pi, or 3 pi over 4, times 180 degrees, whoops, having trouble writing there, over pi. And in this case, we can do a little cancellation here, right? Those pi's will cancel out. The 4 goes into 180 45 times, goes to 1. So we have 3 times 45, or 135 degrees. Okay, so just multiply any radian measure by pi over 180 over pi, and that will change it to degrees. Now, why don't you try that with this? The first one, I want you to go ahead and approximate with your calculator. The second one, I want you to try to leave that as an exact value. Go for it. All right, you're multiplying by 180 degrees over pi. Now, just a side note again, notice there were no units given for this angle measure. Now, I told you it was a radian measure, but even if I hadn't and you knew this was an angle measure, since there's no units, you would have known it was in radians. All right, and notice whenever I'm talking about degrees, I use the degree symbol. Multiply by 180 over pi. Now, 2.5 times 180 is 450. So you get 450 degrees over pi. And I told you I wanted you to approximate that using your calculator, so you found out that you get about 143 degrees to 3 significant figures, right? Okay, so 2.5 radians. There's a little more than 3 radians in 180 degrees, right? So it makes sense in 2.5 radians, there's going to be a little less than 180 degrees as well. Okay, and then for pi over 4, reason I wanted you to leave this one as an exact value is because when you multiply by 180 degrees over pi, you're going to have the pi's kind of cancel out. It's nice when a radian measure has pi in it, because when you ever make the conversion, it works real nice and easy for you. So we ended up with 180 over 4. Still, 4 goes into 180 degrees 45 times, so you end up with 1 times 45. That's 45 degrees, right? 1/4 of pi should be equal to 1/4 of 180, and it is. Okay, now how do we go from degrees to radians? Well, simply we kind of use the reciprocal of the previous scale factor, so to speak, that we were using. In order to find a radian measure from a degree measure, you're simply going to take that degree measure and you're going to multiply by pi over 180. Okay, now let me take you back to where I already showed you some equivalents and show you how that works. All right, so for instance, if I wanted to take 90 degrees and I want to convert that into radians, well, I'm going to multiply by pi over 180 degrees. Now, part of the way you can remember which goes on top is that you always want to try to cancel out whatever units the original thing had, and see if I put the degrees on bottom, they cancel. All right, so 90 times 180, or pi over 180, we're going to do canceling with the 90 and 180. That'll become 1, that'll become 2, and so you end up with pi over 2 radians there, which is exactly what we said 90 degrees was equivalent to. All right, so with that in mind, you just multiply by pi over 180. Go ahead and convert each of these degree measures into radians. And let's leave each of these as exact values. So again, multiply by pi over 180, and see how my units are going to cancel out the degrees and the degrees. So that's a good thing for us. Let's see, 150 and 180 are both divisible by 30. That's our greatest common factor. This would become 5. That would become 6. And then multiply that out, you're going to get 5 pi over 6. There's 5 pi over 6 radians in 150 degrees. And then for 40 degrees, again, multiplying by pi over 180. Well, the greatest common factor for 40 and 180 is 20. This will become 2. This will become a 9 then. There are 2 pi over 9 radians in 40 degrees. All right, you know what a radian measure is. You know how to convert a radian measure to degrees. You know how to convert a degree measure to radians. If so, this has been pretty successful. Thanks for watching, everybody. See you next time.